Hello learners, welcome back to Sir Daniel's Quicksolve Science class. Today we have another wire question on the board. Let's look at how we are going to tackle this question. The question says, the mass of a vehicle is 1000 kilograms and travels at 100 meters per second. If the vehicle accelerates to 150 meters per second, in 10 seconds, calculate I, acceleration of the vehicle, II, for that act on the vehicle, and then III, final momentum, when the vehicle comes to a stop. Now, as we always do, before you start to solve this question, you read the question and then you write down all the vital information before you start to solve. So let's look at how we're going to solve it. Solution. The mass of the vehicle is 1000 kilograms, so we write that one down. Mass, which is 1000 kilograms, and travels at 100 meters per second. Then, if the vehicle accelerates to 150 meters per second, so here the velocity is 2, which means one is final velocity and one is initial velocity. So the 100 meters per second becomes the initial velocity. So initial velocity, which is 100 meters per second. And then if the vehicle accelerates to 150 meters per second, so this one becomes the final velocity. So final velocity equals 150 meters per second in 10 seconds. So the 10 seconds is for time. So time is 10 seconds. Now we should calculate I, acceleration of the vehicle. That is the first one. So let's look at how we're going to calculate the acceleration of the vehicle. So I, acceleration of the vehicle. Okay. So from physics, the formula we can use to calculate the acceleration of the vehicle is A equals V minus U all over T. This is the formula we can use to calculate the acceleration of the vehicle. A equals V minus U over T. Where A is acceleration, and then V is final velocity, or somebody say final speed, and then U is initial velocity, and then T is time. Okay, so the A is the acceleration, the V is the final velocity, the U is the initial velocity, and then the T is the time. So let's substitute the information into the formula. Therefore, A equals V minus U all over T. So A will be equal to V, which is the final velocity. So from here, the final velocity is 150 meters per second. So you write it here, 150 meters per second, minus U, which is the initial velocity. So from here, the initial velocity is 100 meters per second. So minus 100 meters per second, all over T, which is time. The time is 10 seconds. So all over 10. So let's break this one down. So A equals 150 minus 100 give us what? 50 over 10. Then 10 goes into 50 5 times. So A, or the acceleration, equals 5 meters per second squared. So the acceleration of the vehicle is now 5 meters per second squared. Now let's go to the II. The II. So II. The II says we should calculate force that acts on the vehicle. So from the Newton second law, we know that force equals mass times acceleration. Okay, So mass times acceleration. So let's look at the mass from the question. So the mass is 1,000 kilograms. So this gives us 1,000 times the acceleration. This is the acceleration, 5 meters per second squared. So that is 1,000 times 5, and then which gives us 5,000. So force is measured in Newton. So this is 5,000 Newton. Therefore, the force of the vehicle is 5,000 Newton. Lastly, the III, final momentum when the vehicle comes to a stop. Final momentum when the vehicle comes to a stop. So if the vehicle comes to a stop, then it means the vehicle is now at rest. So the speed or the velocity of the vehicle now is 0 or 0 meters per second. So velocity now is 0 meters per second. Therefore, final momentum, the formula is momentum is equal to mass times velocity. So the formula for final momentum here is mass times velocity. Therefore, this gives us mass from the question. Mass is 1,000 kilograms. So 1,000 times velocity. So now, if the vehicle comes to a stop, the velocity is 0 meters per second. So this will be 1,000 times 0. There we know that any number times 0 gives us what? 0. So the momentum now is 0. If you found this useful, like, comment, and share to your friends. Thank you.